Hi everyone, welcome back to my YouTube channel. In today's video, we will start the new chapter, that is semiconductor diodes. In this video, we will discuss the formation of PN junction diode. Before going to start the formation of PN junction diode, we should know some basic information about the diodes. See, a diode is a two-terminal electronic component that allows electric current only in one direction. Means this diode has two terminals, but it will allow the flow of current in only one direction, while in another direction it will block the flow of current. See how the junction will be formed means when n-type semiconductor is suitable for the p-type semiconductor, then these two will form one junction. That junction is called p-n junction diode. So if you want to know about the complete information about the PN junction diodes N-type and P-type, I will give the link in my description. Please go through it once, then you can understand the concepts very clearly. And now we will start the discussing about the formation of PN junction diode. So I already told when N-type semiconductor is suitable to P-type semiconductor, then the junction will be formed. That junction is called PN junction diode or semiconductor diode, or simply we can call it as diode. The formation of PN junction. So here we have two opposite polarities, means N-type semiconductor and P-type semiconductor. In N-type semiconductor we have one charge, and coming to P-type semiconductor we have other charge. Means there are two opposite charges are presented. So opposite charge polarities are attracted. So in the N-type we have electrons, coming to P-type we have holes. So the electrons from the N-type will diffuse from the N-type to P-type. Coming to P-type, in P-type we have majority of holes. So it will diffuse from the P-type to N-type. Like that, the diffusion process will be continuous until the depletion region will be formed. So the width of the depletion region depending upon the doping concentration. So we already know doping is nothing but the adding impurities. These N-type and P-type are the impurities. So we will add more impurities, means we have less bandwidth. So these are the inversely proportional. At room temperature, the potential barrier of germanium is 0.3 and for silicon it is 0.7. Now this is the equivalent circuit diagram of diode, and now we will see the formation of PN junction diode. So here I am showing the formation of the PN junction diode. So let's consider one P type and one N type. So here I am considering P as left side and N is right side. So we already know this N type has the negative immobile ions. So I already told why it has the negative immobile ions, because it will accepting one electron. So by accepting electron, it will forms the negative immobile ions. Coming to N type, in N type we have positive immobile ions. So why it will has positive immobile ions means it will donate one electron. By donating one electron, it will form the positive immobile ions. So in P type we have majority of holes, right? So here I am placing majority of the holes and some small amount of electrons, that is 1 2 3 is enough. So coming to N type, in N type we have majority charges or electrons, right? So we have majority of the electrons, that's why here I am placing most of the electrons in N type and very few number of holes. Here I will indicate these with some names. So this is hole, which is minority charge carriers in the N type. This is the electron, which is majority in the N type, and these are the positive immobile ions. So positive immobile ions are occurred by donating one electron. So by donating a electron, it will form the positive immobile ions. Coming to P type, so in the middle of this it has the junction, so that is known as the PN junction, or we can call it as semiconductor diode junction, or we can simply call it as junction. And coming to p-type, so these are the negative immobile ions. So it will occur negative immobile ions by accepting the electron, and these are the holes which are majority charge carriers in the n-type, and these are the electrons which are minority charge carriers. To understand this clearly, so just see that video so you can get some clarity about it. So up to now we will see that n-type and p-type and these immobile ions, and now we will see the diffusion process. So I already told, when the two opposite charge polarities are there means the attraction will be done. See here, in n-type we have positive immobile ions. In p-type we have negative immobile ions, means these two are in opposite charge polarities, right? So these two will attract each other. See, here I am showing this in n-type the positive immobile ions are moved towards the p-type, and in p-type we have negative immobile ions, they are shifted towards the n-type. Like this the process will be done. This diffusion process will continues until the barrier potential will be formed. So here I am showing the barrier potential. So this is the barrier potential. Up to formation of barrier potential, the diffusion process will be continued. So now the depletion region will be formed, and now the diffusion process will be done. And here I am indicating in n-type it is cathode. Coming to p-type, it is so, and the formation of p junction diode, and it is very simple. So just it will form one n-type and p-type will be formed due to the opposite charge polarities. The diffusion process will be done. So the diffusion process will continues until the depletion region forms. Once the depletion region formed means the diffusion process will be stopped. And this depletion region width depending upon the doping concentration. So doping means here the when n-type and p-type are doped heavily means the width will be reduced. Means these are inversely proportional. So this is the formation of p-n junction diode. In next video we will discuss topic. Until then, don't forget to subscribe my YouTube channel and share this video with your friends, and thank you for watching. Keep supporting.